1-3, linear functions, slope, and applications. On page 92, it has some examples of some linear functions and some nonlinear functions. So these are my quadrants, which are awful. So linear functions are always just straight lines. How about I pick a straight line? Okay, so it can be any straight line. Okay, the one thing it can't be is up and down. This is not a linear function. Okay, other than that, as long as it's not straight up and down, it's a linear function, as long as it's a straight line. Okay, so I just drew a couple graphs and some examples of a constant function on this graph. A constant function is going to actually be at y equals something. So the equation for a constant line, in this case right here, will be y equals 2. So this was 1 and 2. Okay, in general, we just say y equals b. So b is just whatever number it is. In function notation, which is really what we've been using, we'll say f of x equals b. And remember from your y equals mx plus b equation, b is your y-intercept. Your y-intercept in this case is 2. A general equation would just be y equals mx plus b. In this case, this is b. And the rise, I don't have any good points, so from here over to here would be our slope. Okay, we'll talk about how to actually calculate slope too, so hopefully you guys already know how though. Okay, and this equation we've always seen y equals mx plus b. In function notation, we'll have f of x equals mx plus b. And we also have our identity function. Our identity function will just be up 1 over 1 will be our slope, and our y-intercept will actually be right at 0. So our identity function, our b equals 0. Our slope, we go up 1 over 1. So that's 1 over 1. And so our identity function is f of x equals x. So it's basically 1x plus 0. And we just write f of x equals x for identity. And also to talk about horizontal or vertical lines. Vertical lines, although they are not functions, remember that piece of it, they are written in the form of x equals some number, in this case 2. In general terms, we'll write x equals a. And I lost my little pauser deal. Okay. On page 93, you're given a couple different examples, and they actually have some numbers listed out for you on the number line or on a table of values. So what we're going to do to actually test and see if some functions are actually linear. So they give you an example of one that is and one that is not. You will first see if your x's go up by the same amount and if your y's go up by the same amount. So on the left side of page 93, we have the following values. So I actually left out a value of what they actually gave you, but what you're going to do each time is test to see what the change in my x values is. In this case, it's 10. Sorry that I have sloppy zeros today. 10, so I have 10s everywhere, but right here I have a 20. So now we need to actually check out and see what my y values are going to do. As long as my as long as my x values are staying the same distance apart, we need to make sure that these also stay the same distance apart. So 50 to 100 is 50, 100 to 150 is 50, 150 to 200 is 50, and 200 to 250 is 50, sorry. And 250 to 350 is actually 100. So as long as I can actually divide these two numbers, so 20 divided by 2 equals 10, and 100 divided by 2 equals 10, or equals 50, I'm sorry. As long as I can do that and get the same number that I was getting before in my pattern, that's fine. If you can basically stick that middle value in there, and they actually have that given to you. I just want to show you an example of what that would look like if they didn't actually give it to you. Okay, so you just finish by writing like, yes, it's linear. And now I'll go ahead and write the function values that they give you on the right side of the page. Okay, so to look at those differences in this graph, which when you actually graph it, you can see that it's not linear, but if you're just given this table of values, and probably instead of y, you should probably actually put f of x. Okay, but from 10 to 20, we have 10, so we're going up by 10 every time, so that's a good thing. But then I start going up by 20s, and then 40, and then 60, and then 80. So actually, the first time when I went from 20 to 40, I could have stopped right there and said it's not linear. Okay, if you're looking at a graph of it, you can tell pretty quickly, but the questions in the book give you an actual table of values to look at. Okay, and then to talk about slope, hopefully we've seen a lot of slope. We use the letter M to say that that's slope, to represent slope. Okay, in general terms, we have x1, y1, parentheses, and x2, y2. Okay, remember that the subscripts, the 1 and the 2's on the bottoms, are not exponents. Okay, and we have a few different ways that we try to remember slope. One of those is rise over run. So run is left to right, so this is up, down, and this is left, right. Okay, we also remember it as the change in y. Oops, I forgot the word in. Change in y over change in x. Okay, we also, instead of actually writing out change in, we write the delta sign, which actually represents change. So change in y over change in x. And we can think about that in two different ways as well. And these are basically all exactly the same thing. So I have y2 minus y1 and x2 minus x1, or y1 minus y2 over x1 minus x2. Remember that it doesn't matter which order you subtract in as long as you do it the same from both points. Okay, I just drew out the graph that's on page 94. So some of the points that they gave you would be at 3, -1, and 9, -5. Okay, there's also a couple other different points that you could use. They will all get you the same slope. So to go from these 2 points, I need to make a right triangle. So I just go down and make a triangle. Okay, so how far up or down do I have to go? And this would be 4. And how far left or right do I have to go? So 2, 4, 6. So my slope is rise. So I rose 4. And I went over 6. And now I need to look and decide if it's positive or negative. So always read it like you would a book. So from right here to over here, did it go up or down? Since it went down, it's -4 over 6. Okay, you could also think about it as I went down 4, right 6. Okay, Another way you could also think about it is if I started here and went to 3, -1, I went left 6, which is -6, and then I went up 4. Either way, I'm still going to get that -4/6, which will reduce down to -2/3. Okay, and to see that out in actual in the function notation, so along with the y's, the change in y over change in x, they also tell you to use change in f of x instead of using change in y. It doesn't matter, it's all the same thing. So change in f of x over change in x. So what they do is they actually say, what is my function value at 3 minus my function value at 9 over 3 minus 9. Okay, well 3 minus 9 on the bottom is going to give us -6. The function value at 3 is -1. So I have -1 minus the function value at -9 is -5. So I put that in parentheses to keep track of my negative signs. So I have -1 minus -5, which will become -1 plus 5, which will be -6. -1 plus 5 will give us 4 over -6, which will reduce down to -2/3. Okay, so this is more of the, not necessarily algebraic way, but the numbery way to do it, and this is the graphic way to do it. This is actually using a graph is kind of also how I picture using the distance formula as well. Just a quick example that you could do like 4 squared plus 6 squared, and that will give you the square root of 16 plus 36. We're not actually doing that, just so you can visualize it. So when I figured out my slope, if my 4, if this was going to be a positive slope, the 4 and the 6 right here would either be both positive or both negative to get a positive slope. As long as one of them is negative, as seen like kind of over here in my little picture, then I have a negative slope, or you can just look at the graph to figure it out. Okay, just to compare graphs. So if I have a slope of 1/1, I will go and with a y-intercept, a b of 0, 0. So I will go up 1/1. If I have a slope of 2, I will go up 2/1. So from here to here, I went up 2, right 1, up 2, right 1, up 2, right 1. Okay, and then to see one more with a slope of 3. So I can go up 3, right 1. Okay, so from here to here, I'm going up 3, right 1. Up 3, right 1. Okay, and then the book kind of talks about the difference between a horizontal line and a vertical line. Okay, when you have a horizontal line, whoops, sorry, I hate this thing moving with me. A horizontal line, if I have 2 points on it, whatever these points will be, so we will just say that this is 1, 2, and this is 3, 2. Okay, so my change in y over my change in x values. So both my y's were 2, so I'll have 2 minus 2 over 3 minus 1, which will equal 0 over 2. If I have 0 halves, I still don't have any halves in my pie. So that is actually 0. So a horizontal line will always have a slope of 0. And then it talks about a vertical line. vertical lines and horizontal lines have totally different slopes, and don't get them confused with each other. So if I have, we'll say this is -1, -2, and this is -1, +2. Okay, my change in my y's, so my y's went from 2 minus -2 over -1 minus -1. Okay, make sure you actually pay attention to those signs. 2 minus -2 will become 2 plus 2. So that will become 4 on top. And then -1 minus -1 will become -1 plus 1, which will become 0. And I can't divide anything by 0. Basically, the reason you can't divide pi, you can't divide a pie into 0 pieces. Okay, I guess you could eat the whole thing. Oops, here's my eraser. This is called not defined or undefined. I don't care which word you're going to use. I often use DNE for does not exist. There are quite a few word problems asking you to find either the rate of change or the slope or the grade, and then they give you a few numbers. So if they tell you a percentage, like a 2% grade, where's my pen? A 2% grade. So oftentimes on passes you see like 6 or 7% grade. 2% really mean, remember that percent means per 100? So I have 2 per 100. So I am going down 2 feet, up or down 2 feet per 100 feet that I go across. Okay, so that would look like on a picture. I would go 2 feet up or down and 100 feet across. Okay, hopefully your slope will be a little more stable than that. One of the examples says that construction laws regarding access ramps for the disabled state that the vertical rise, so vertical is y, so think of vertical over horizontal. So the vertical change is 1 foot for every 12 feet for a disabled ramp. Okay, they want you to find the slope or the grade. So I will do 1 divided by 12, which gives you 0.083. And when I ask for the grade, I always want it in an actual percentage. So it has to be in a percentage. Okay, so I have to transfer this to a percent. So that would be 8.3% grade. Okay, on page 99, they have another example asking you to find the average rate of change. So again, you're just doing y minus y over x minus x. Sometimes looking at the graph, I don't know about you guys, I have some other kids that sometimes forget my x's and my y's. Remember that when I'm actually given a word problem, no matter even if I haven't seen the graph, my x's are always, or usually my time, the thing that doesn't change. The change in time is not going to be any different. So this is like the one that's going to vary on top. Okay, that's what we're actually looking at. So for the snowboarding thing, okay, it had started at 336,966, and that was in the year 2005. And then I'm going to subtract from that the sales from 2009, so 287,524 minus 2009. Okay, if you notice 2009 is bigger than 2005, so that's going to give me -4. So that's a 4-year difference. And 287 is smaller than this one. So I'm going to have a positive number on top, and they tell you that that is 49,442. So since I have different signs, so I will have a negative slope, and they tell you that is -12,361, 12,361. So snowboard sales have gone down at about that time. We talked a little bit about the slope-intercept equation. Didn't necessarily call it the slope-intercept equation, but we have f of x equals mx plus b. We have always seen it as y equals mx plus b, no different. This is your slope-intercept form. Okay, so if I were to just have a general equation, and this was my mx with that same slope, I'm going to have mx plus b. This here is just mx because it goes through 0, 0. So basically plus 0, but we don't write that. If this was our b here, this would be mx plus b. So we have to go through and find our slope and find our y-intercept. So remember on a few of the questions, if you have a number over 0, that is undefined for your slope. And if you have 0 over a number when you find your change in y's over change in x's, that is just 0. Don't get those confused. And I'm going to go back and change something on one of the other pages where I said, I don't even see it, where I said varies over time. Instead of time, they just use the term fixed. Time is something that's fixed, but they might have other examples of fixed costs as well. And what they really use fixed costs for, I didn't actually have to go back to change that one. Fixed costs will be when I'm writing an equation. The fixed cost will be my y-intercept. Y-intercept, which is b, and the variable cost will be my slope, which is my m. So number 77 asks you to find C of t, and it tells you that the phone originally cost him $89, so we add on $89 because that was a one-time expense. And then we are going to spend $114.99 per month. Since it's per month, it's times every month that we have, so 114.99 times t plus $89 is our function. Okay, and then it asks us to find the cost after 24 months. So we're going to write 114.99 times 24, and we're going to still add in the 89 that we have there. So 114.99 times 24 is $2,759.76. We're going to add $89 to that. And our total cost after 2 years of having this phone and never getting a new phone in that 2 years is $2,848.76. So that's what some of those word questions will ask you to do. So for questions, I want you to do the matching on page 102. And then on the next pages, I want you to do on 103 numbers 3 through 84 by 3s. The last two questions is just kind of some skill maintenance things.